Okay, so by warm up, we're going to continue on with distributive property. For those of you who are away, the only thing I asked was, or I got you to think about was, if I have something, a term in this case, in front of, aka multiplying with a bracket. This bracket serves as a single body, so everything inside the bracket is being multiplied with the term. You will take whatever term is in front and give it an opportunity to multiply with everything inside. I don't care if there's 2 terms. I don't care if there's 3 terms. Whatever is multiplying on the outside will get a chance to multiply with every term inside the bracket. So it's just a matter of being able to multiply correctly. Here we go. Oh, another thing I talked about was if you're having some trouble with this, assume when you are multiplying terms together, coefficient with coefficient, variable with variable. What do I mean by that? A -3, I don't have, you might have to deal with a pen for now.
Thank you.
Okay, a -3 is multiplying with a +1. So -3 times 1, -3. Next, the variable a is multiplying with the variable a. A times a squared. Next, -3 is multiplying with a +1. So it's -3. A is multiplying with a b. Well, they're different variables. You can't do anything with them. You just leave them as a times b. Done. I'll go a little bit faster.
Wait, why is it -3 to the a?
Well, this part right here, okay, this part right here, it's -3a times a. So -3 times 1 is a -3, and then a times a is a squared. All right. Please also know, in terms of showing your work, this is all you need to show me. You don't need to do anything else, no more, no less. If you show me this as a next line, I'm not going to insult your intelligence. I will assume you are doing it correctly. And again, I'm going to sound like a broken record. I don't know who may have asked you to show your work like underneath here and, you know, -3a times b equals -3ab and then like draw an arrow or whatever. I don't know who might have trained you to do that. We're going to have to unlearn it. Moving on. Here's my term, 7x. It gets an opportunity to multiply with everything inside. 7 times 1, x times x. 7 times 1, x times y. That's it. No more, no less. So questions like this, you can assume is like a 1K mark because it's a one-step straightforward question. Oh, well, there's an x times y inside. So 7x is going to be multiplied with x. And whatever that is will be added with whatever that is.
Why the first one is there minus?
Oh, a -3. A -3 is being multiplied with a +1. A -3 is being multiplied with a +1.
What? Yeah.
Okay, so you can say -3a squared is going to be added with a -3ab. Yeah, so I just, yeah.
Okay.
Yes.
Did we already deal with the x first part? So then why would this convert to 7x?
Oh, once again, if there's a term multiplying with with a bracket, it's multiplying with every single term inside the bracket. Yes, aka distributive property. You're distributing it to everything. It's just mathematician, so creative, right? That's it. Let's try it one more time. Even if it looks scary, we're not doing anything different in terms of the mathematical procedure. Yes, you'll have to use exponent laws here, but let's move on. Coefficient with coefficient, variables with variables. So again, how about coefficient with the coefficients? And then variables with the variables, okay? Here we go. -5 times a 4 is a -20. Oof. X squared, there's another x there. That's 3 x's multiplying together. That's x to the power of 3. Here's a single y multiplied with y times y times y. There are 4 y's there. They're multiplying. -5 times a -3 is going to be a +15. I have 2 x's multiplying, and that's multiplying with another 4. I have 6 x's multiplying. The y value isn't multiplying with anything else. It's just y on its own. There's no other y's to multiply. So there we go. And lastly, -5 times -2 is a +10. X squared is multiplied. Oh, there are no other x's. It's just x squared. And the y multiplies with the y. That's y squared. Yes, Ellie. Ellie, question?
Oh,
So here it is. Yeah. So again, even if it's a trinomial, you shouldn't necessarily be tripped up about it. Letter A is basically the same thing as what we just did. I'm going to jump to, I don't know why it's called C, but I'm going to jump to the harder one on the middle right of the page. And while we are waiting for people to follow along, remember, 4 is only multiplying to the bracket next to it. And then 6x is multiplying to every term inside. You will see that some of the terms suddenly become like terms and you have to group it. I'll give you a minute. See if you can get the first line out of this and expand the, I guess, the expression. Okay, so if this was a test question, you would see the word expand and simplify. The first step is expanding. Go ahead, please. See if you can multiply it out. So yeah, the word expand from the previous lesson is whatever that term is, multiply it in and get rid of the brackets. So do what we were doing just now. Take the term in front, multiply into the bracket. Take the 6x, multiply into the bracket. Go for it.
4x.
Correct.
Negative 1x.
Correct.
Positive 18x to the power of 2.
Correct.
And negative 12x to the power of 3.
Correct.
Negative 12x.
There you go. Excellent. And that's it. So we've expanded. Yep.
So when there's like another part of the question,
Mhm.
how do you use the like original number? Like you wouldn't take 4, you would take 6.
You notice how this part and that part are separated by a addition?
Yeah. So you would start.
Yeah, so you could think of this part and that part as two different parts of the statement. Think of the plus or a minus as like a space in an English sentence or like a period in an English sentence. They're separate things and we'll bring them together afterwards, right? Good question. From here, now we are going to do that thing called simplifying. And that is, notice that x squared and x squared are found in these two terms. And a single x are found in these two terms. So they are like terms. I am going to leave this one first, and I'm going to write it first because it has the largest degree. And then x squared is 4 plus 18. That is 22 of these x squareds. And then I have negative 20 with a negative 12. That would turn into negative 32 of the x's.
I have a question.
Mhm.
So for 20, when
Mhm.
it's like negative 20, wouldn't it be just like isn't the negative sign not like part, like wouldn't it be part of the sign?
So you're wondering, is this negative 20 or is it minus a positive 20? Is what you're asking? Would it confuse you if I said they were one and the same?
No, but I'm just wondering, like, does it solve the question solve any differently? If they are-
No, it shouldn't. It shouldn't. So if I did negative 20 subtracted by a positive 12, for example, right here, you should still get negative 32. It's like I'm $20 in debt and I take away another $12. You can think about it like that, right? So it's negative 32.
Only reason why I asked is then if it's like plus 18, wouldn't you usually just write 18 if it's part of like, if it's not positive, right?
You would. There's nothing wrong with writing it positive 18, but if you wrote just 18, it's automatically understood that it's a positive. So it's a waste of your time to actually write it. That's all. But it is always plus. Okay. That's it. So let's do this geometry. Hint, hint. Please be wary of the geometry because a question like that might pop up in the future. You want to try A? I can give you the final answer. Of course, I'm going to make an answer key. But if you simplified it, the final answer would be a positive 7x cubed, a positive 56x squared, and a positive 63x. Okay? So try it and try it on your own, and then you can compare your answers with the answer key I'll put online. I really want to get to this part. Some people are still copying, so yeah, finish that part off. For everyone else, take a look at that geometry shape. Determine the area of the given diagram. Length times width, right? That's all you know. There is no formula for this little hook-like shape, but we do know the formula for rectangles and squares. So how about we take this composite shape and break it apart? Right. I forget, I think composite shapes, you've seen composite shapes, correct? In elementary school and middle school? I think so. Let me refresh your memory. As I was saying, you don't have formulas. Some people love formulas. They love memorizing formulas. And they love the fact that as long as they plug in numbers, you get what you want. Now, this is not a shape. However, I do know that's a shape. And that's a shape. I have 3 rectangles. If you don't like that, I could do it as that and that. Or if you don't like that, I could do it as that and that. You get the point. The goal is taking this weird looking shape, we can break it apart into pieces that you are familiar with. That's all. So is everyone okay if I cut it like this? Is everyone okay with that? All right. We will call this piece number 1. We will call this piece number 2. And we'll call this piece number 3. 1 and 3 are going to be easy. Area of 1 is length times width. Take a look. Here's my long side. Here's my short side. Hey, it gave me the short, long side and short side. Length times width is the same as 2x times x. Simplify that for me. Sorry, I heard a whisper, so I'm just going to go for it. Thank you, though. I appreciate it. And as I said before, I'm doing part 3 because it's given to me. Take a look. Length and width. So the area of part 3 is, again, I'll write it out, length times width. That's going to be, I hope you're not confused if I write it this one first. 2x minus 16 times x.
How's that supposed to give you the area?
You'll see. Think about it. Think about it this way. Here's the idea. If in this bank account you got $5, in this bank account you have $100, and in this bank account you have $1,000, how much do you have in total? What would you do? There you go. Same thing with area. In this part, let's say you had 5 centimeters squared. In this area, you have 100 centimeters squared, and here you had 1,000 centimeters squared.
So what I meant, like, if you have like one of the lengths, how is doing like 2x in bracket with x, how is it supposed to give you the area of that one piece?
Oh, it is because we don't know what the value of x is. But if I told you that x was 1, suddenly the area becomes 2 times 1 squared, and you get the answer. So right, the whole point of algebra is that you don't know what x is. So you're right. There we go. I have a bracket and a bracket multiplying. Maybe if I write it like this, you would prefer it, like writing the x first. It doesn't matter. And if you distribute it, this becomes 2x squared minus 16x. You get the same answer, so please use whatever way you want, whatever makes sense to you. And then, ooh, number 2. What's my length? Great. What's my width? We got 2. Should I flip a coin? So you have an idea?
X minus
Where do you get those numbers?
3x is the side length of 1 and 2.
Right.
And
Uh-huh.
we do minus 2x, that's what we're not counting.
Right. It's like you have this, like, you know, the extra large chocolate bars, let's say, and then you come home one day and like this much is chopped off. Same idea. Why? Because your baby cousin got to it somehow. I don't know. Right? Same way. So this would be 3x. Sorry, let me write this down then. That would be the long length 3x and take away the shorter length 2x. 3x minus 2x, group like terms. You would get 1x. If you don't believe me, well, let's check the other side. That entire length is 2x, and this shorter length is 1x. Does it work? 2x, take away the shorter length 1x, well, group like terms. 2 minus 1 is x. I think we got it. The width of that part is just x. So my formula length times width is 6x minus 24 multiplied by a width of x. Again, let me rearrange it so that you look familiar. It looks familiar to you, but again, if that part makes sense, then use it. You don't have to waste an extra line. The final answer is 6x squared minus 24x. Pause. Are we done? We did a lot of work. Hey, you should deserve some marks, right? But are we done?
first line, it's.
Mhm.
What's the reason?
I was afraid people might be confused if the smaller of the two terms is not in front. But let's say you didn't care and you remember that every single thing inside the bracket multiplies with everything else. You would do 6x times x, which is 6x squared, and then negative 24x, which is negative. You could do it's the same stuff. Okay. Anyways, my final step, going back to my original question, is to calculate the area of the total diagram. So that means it's the first area, the second area, and the third area all together. So we've got 2x squared as the first area, right? The second area, 6x squared minus 24x. And the third area, 2x squared minus 16x. This type of question was in your homework on Monday. I'm wondering how many people are able to exercise their muscles a little bit. Tell me what the final answer is. I'll give you a minute. Maddie, question? Right. Let's give it a shot. This is going to take you into the, good, I guess, preparations for the quiz. Yep. Yeah. Correct. Okay. So if you had this and you were going to go through each step like facetiously, okay, I'm not going to use the big words like that. If you're going to go through these words sarcastically, right, just to, entertain Mr. Kim, know that every single one of these brackets has a 1 in front of it, right? And you don't have to worry about those brackets. This actually equals to 2x squared, 6x squared, minus 24x, plus 2x squared, minus 16x. From there, again, I didn't say anything, but if you wanted to simplify it, you would recognize that these three terms are like terms because they have the same variable, x squared. These two are like terms because they have the same variable, x. So I will group them. 2, 6, 2. That's 10x squared. Negative 24, negative 16. That's negative 40x. Yes. Pardon? I am adding, I'm not multiplying. Right? The 2x squared plus x squared is like saying 2 of those big algebra tiles plus another one of those algebra tiles. How many of those algebra tiles do I have? I have 3 of those algebra tiles. But when I multiply, it's a little different. I'm going to allude to your exponent laws, right? If I have 2x squared multiplying by another x squared, the idea is, remember, the coefficients, 2 times 1 is a 2, x squared times x squared, x to the power of 4. I know it can be confusing. I'm going to say that's where practice will come in. It has to become muscle memory. One last thing I'll do for you, Arvid. Remember that this, if I were to expand it, this is 2 times x times x times x times x. 2 times x times x times x times x. So that might look better for you. Okay? So know the difference between adding and multiplying. It's a big one. Any questions? All right. So I'm going to push you. I'm going to go through one more without doing any of the homework questions by introducing, some of you may have seen it before, square brackets. Has anyone encountered square brackets before? Got 1, 2, 3. Square brackets are literally brackets on top of brackets. There's no special meaning. Okay? So don't feel weirded out. You're still going to follow the same information. Square brackets, you could think about it as adding brackets in there so that you don't confuse yourself with parentheses, the curved brackets. So here we go. Consider this. Let's work on this bracket first. Because as you know, at mass, you want to do the brackets first, right? But within that bracket is another bracket. So maybe we want to work on that first. Let's do it. Let's simplify. 5 is going to multiply with the 2, okay? It's going to multiply with the -1. So what is happening here? Let me rewrite this a little clearly. 5 times 2k is a 10k. 5 times -1, -5. That's what's happening. So nothing special. So let's simplify the inside. I wrote too big and I'm running out of space. So this is what? 10k, 2 plus negative. So 10k is on its own. There's no other like terms. 2 and -5, -3. Treat the square brackets like normal brackets. So by distributive property, this becomes 30k subtracted by a 9. 2 steps. Done. It's essentially another set of brackets. We just want to make sure you don't confuse yourself with where does a bracket start, where does a bracket end. Let's do one more. We'll do B, and then maybe I'll jump to D. Bless you. Negative. So again, I want to draw your attention. I have to simplify the bracket first. Within that bracket, there's another bracket. So let's work on that. By bed mass. -5, bracket, bracket. 4 times m, 4 times 3, that is 4m plus 12. We'll move on. -5. Let's simplify. 4m is all alone. There's no other m variables around. 12 and -3, that's a +9. And now suddenly it looks more familiar. You have a term multiplying through a binomial. This is -20m minus 45. No, I take it back. I'm going to challenge you to try this on your own. The final answer to this one is oh God. 35 -30. +16. I think. I'm going to double check that right now, but try it. Yes. Yes, of course. Oh, we still have like 20 minutes, don't we? I'll do it soon. Oh, really? Yeah, I'll get it. Okay. So at this time, I'm going to sort of set you free. Would you please try it? There are, I guess, 3 large homework questions you can try, with number 3 obviously being a more challenging one. It's going to be a good preparation for your quiz coming up on Monday. Please do what you can. The answer key will be a bit like, I don't see an answer key here, so I'm going to make an answer key and I'll put it up online for you. Okay?
I found my homework.
Any other questions? All right, let's try some practice questions.